Welcome to the deep dive. You know, you see these incredible videos, right? Starlings, thousands of them, twisting and turning together. Or schools of sardines, just impossibly dense, yet they never crash.
Yeah, perfect coordination. It's mesmerizing.
It really is. And then,
Yeah, dude.
then you think about us, humans, in rush hour traffic. A single distraction, someone brakes too hard, and bam, gridlock, collisions. It's chaos.
It's a stark contrast, isn't it?
So today we're diving into Iain Couzin's work. The big question is, how do these animal groups pull off this amazing, fluid, leaderless organization? And frankly, why are we so bad at it?
Well, the fascinating thing Cousin's research points to is simplicity. We tend to look for, a leader, some complex plan, but it seems to boil down to just a few basic rules governing local interactions.
Local interactions, meaning what exactly?
Three core things, really. Repulsion, basically. Don't bump into your immediate neighbor. Keep a little space. Attraction, stay generally close to the group. Don't stray too far.
Okay. Repulsion, attraction.
And alignment. This is key. Just try to match the speed and direction of the neighbors you see right around you.
That's it. Repulsion, attraction, alignment. It sounds almost too simple to explain something like a murmuration.
But that's the beauty of it. Complex, large-scale patterns emerging from incredibly simple local rules. No grand overview needed.
So if we just follow those rules in traffic, keep your distance, stay with the flow, match speed, maybe rush hour wouldn't be so bad, but we overthink it. We rubberneck, we get distracted.
Exactly. We introduce all this other complex behavior. Look at ants, though. They're practically blind, living in these huge colonies, sometimes millions strong.
Right, I've heard about this.
And they spontaneously form lanes on their trails. Two-way traffic, minimizing jams, maximizing how much food gets back. They figure out traffic control without a central planner.
Just based on local cues, I assume? Bumping into each other or sensing chemical trails?
Precisely. Low-level rules creating high-level order. But what's really mind-blowing is that this organization doesn't always come from, nice cooperative intentions.
Oh, how so?
Okay, get this. The desert locust swarm. Probably the most massive coordinated movement of animals on the planet.
Looks incredibly purposeful, like they're all marching together.
It looks like cooperation. But Cousin's work showed it's driven by, well, cannibalism.
Wait, what? Cannibalism drives the swarm?
Yeah. The fundamental rule for an individual locust is brutally simple. Avoid being eaten by the locust behind you. And maybe try to eat the one in front if you're hungry.
So it's a forced march. Move or get eaten.
Exactly. It's sheer terror propagating through the group. They even proved it experimentally. If you cut the nerve that let the locust feel something touching its abdomen, essentially, feel the guy behind trying to bite it, that locust stops swarming. It rocks out.
Wow. So this incredibly organized, massive phenomenon is built on a foundation of pure, aggressive self-interest.
It turns our ideas of cooperation on their head, doesn't it? Simple, even aggressive individual drives can lead to highly structured collective behavior.
Okay, so survival instincts can drive movement, but what about, actual group decisions? Choosing a direction, finding food. How does that work without a leader?
That leads to another fascinating area. Couzin explored group decision-making and how easily it can be, hijacked.
Hijacked.
Yeah, they did this experiment with fish. They trained a small minority, just a few fish, to strongly prefer a target. A yellow marker, I think. It was like the crack cocaine of the fish world was how someone described it. Super attractive to them.
Okay, so a few fish were really, really motivated to go towards this yellow thing.
Right. And what happened? This tiny, strongly opinionated minority completely dictated the direction of the entire school. They just dragged everyone else along.
So the strength of the preference, even in a few, overruled the, indifference of the majority.
Exactly. Which raises a big question, right? How does a group avoid being constantly dominated by the most extreme opinions, whether they're right or wrong?
Yeah, that sounds relevant to humans, too.
Definitely. But here's the really cool part, the aha moment. They wondered what would happen if you added just a few uninformed individuals to the mix. Fish with no preference for the yellow target.
Uninformed ones. You'd think that would just add noise, make things worse.
That's what intuition might suggest. But they added just a small number, maybe 5 or 10%, who were totally unbiased. And guess what?
What happened?
Control shifted back to the numerical majority. The uninformed fish, sort of, diluted the influence of the extreme minority. They acted like a social glue, weirdly enough.
So having some individuals who don't have a strong opinion actually makes the group more democratic, less likely to be hijacked.
Precisely. That bit of messiness or noise prevents the loudest voices from always winning. It allows the group's collective wisdom, the majority preference, to emerge.
That is completely counterintuitive. We always think more information, stronger opinions are better.
Right. But it turns out, especially in large groups, you need surprisingly few informed individuals, sometimes less than 5%, for the whole group to make a really accurate decision, like finding the right way.
So it looks like everyone knows where they're going.
But really, it's the few who know influencing the direction and the uninformed majority providing the stability and democratic balance. Collective intelligence emerges from this mix.
Okay, let's try and wrap this up then. The core idea seems to be that this incredible collective intelligence, whether it's movement or decision-making, doesn't need master plans or complex individual thought. It bubbles up from the bottom.
Exactly. Simple rules, local interactions, avoid a bite, match your neighbor's speed, even just being uninformed. These can generate sophisticated group behavior without hierarchy.
It's a different way of thinking about intelligence itself, not just individual brains, but network effects.
Absolutely. And that leads to maybe one last provocative thought for you to consider. Based on Cousin's later work on how ideas and behavior spread, he talks about complex contagions.
Complex contagion.
Yeah, the idea that, unlike a simple virus, some behaviors or beliefs need reinforcement. You need to hear it or see it from multiple sources before you adopt it. And his research suggested something fascinating about influence in social networks.
Okay.
We often think having lots of weak ties, knowing many people superficially, is best for spreading influence. But his model suggested that for these complex contagions, the most influential people are often those with fewer but stronger connections.
Fewer, stronger links are more influential than many weak ones. That's also counterintuitive.
It is. It suggests that deep trust and repeated exposure through strong bonds might be more critical for changing complex behaviors or beliefs than just broad reach. So maybe think about that. Who do you listen to? Who really influences you? Is it the person with the most followers or the ones you have those deeper connections with? Makes you reconsider how influence actually works in our own lives?